Whoa, got it.
Me too.
I hope. Hi there, everybody. Hope we're broadcasting bad breath, all of us here in early October with episode 32 of your SBAU Astro Hour, Santa Barbara's astronomical unit. I'm Baron Heron, your host for a Monday podcast we do every Monday morning, 11 till noon. You can leave comments, ask questions, get on board. Slowly building our audience. We're also on YouTube. We got a channel there. And this week, we're going to talk about a lot of small celestial bodies, all large for their categories. We're going to talk about 3 big asteroids if we get to them. One of Saturn's shepherd moons for the rings, and the largest comet ever seen. Might even, Mira, the variable star of the month of October, is on front burner for the astronomical units. SBAU Astro Hour. Let's meet the gang. We got 5 of us here. Ladies and gentlemen, your president, I'll stand, play Jerry Wilson.
Good morning.
Married to Pat Forgy, and he's our president for 3 seasons, even though you don't see him except on TV screen. Chuck McPartland, outreach coordinator, also married to our merchandise manager, Pat, and doing outreach by himself up at lakes and city parks on the beach and things like that. Tom Whittemore joins us.
Good morning, everyone. Good morning.
Got his eye back and turned in that damn loaner they give you, and you're good to go. Tomorrow he'll have a new batch of bread for all of us. How's Maureen doing?
Oh, she's fine. She's actually had a nice walk up the hill right now.
Bless your heart. And then Tom Totten, my buddy there, Tom, who's married to Suzanne, a very artistic lady. Webmaster, technical wizard, former president. Welcome aboard. We may be joined by Bruce Murdoch and I think Tim Crawford, who used to be, I guess, the guy behind our Tuesday night telescope workshop, which is still on, but he's more or less participating in your running that show, right, Tom Totten, tomorrow night?
Yeah, I get it going, but I hope for other people to show up, so I just sit there and watch.
And President Jerry's on board. But I got to tell you, this is the line I heard. I wonder if you guys have ever heard this in the form of a adage or a cliche, but apparently somebody has said that time machines do exist on Earth. They're called telescopes.
Right. Yeah.
Because
that's
exactly.
That's always been a favorite. You know, I would tell people who'd come to the workshop, you know, we'd build time machines.
But only toward the past.
Yeah.
This is not up for a big subject, but I've always wondered, they can figure out with computers where different stars and galaxies are going to be in a few years, or by now, or they can predict how they're going to be. So why can't we get a view of the universe as it looks today based on computers moving everything to where they should be?
You can, but it's just on a computer screen.
I've never seen one of those. I'd like to know.
And as you get farther and farther into the future, it becomes less and less certain because you can't take into consideration every possible combination of interactions.
Is that right?
Yeah.
It's a lot of work for not much gain.
Yeah.
But those really distant galaxies are totally different places and different sizes, and they're totally different today. They're farther away, though. I understand that.
Yeah, they might be much bigger.
Well, gentlemen, hey, welcome aboard, Mr. BKM. There he is, ladies and gentlemen. Our good friend from the Santa Barbara Theater Organ Society now joins us. Bruce Murdoch. You have problems getting on, Bruce? Bruce, turn your mic on. Bruce will be joining us momentarily as soon as he gets his voice back. You're not plugged in. Well, he'll join us.
For some reason, it went to mute.
Well, that's typical technology, isn't it? That's why I know AI.
Somebody pushed a button.
Well, you got your talking points too, Bruce, like the rest of us from President Jerry. And I guess we'll probably go to the variable star of the month. We have those, and this one's called Mira. It's also cataloged by the AAVSO or U. I can't tell what that was.
AAVSO.
Oh,
Right.
Okay. As Omicron Ceti.
Yes.
Rises in the east as the sun sets in the west. Get some graphics called up here by Tom. To the left is bright star Menkar, the Wales Alpha star. New Delta And apparently
That's-
Delta's not on there, right?
That's alpha,
Yeah,
Oh.
that's alpha. That's Mencar. And
right?
delta is where the M77 marker is.
Yeah, down, there you go. Not that one, this one.
There. Yeah.
Okay, there's something about this. It's like a year cycle, right?
Yeah.
Brightening and
But yeah, 11 months roughly. Uh-huh.
you want to explain more on this? What are variable stars? First of all, we get about once a month a new one that we adopt and talk about. There it is. There's Mira's cycle.
Yes.
And you can see each of those numbers along the bottom just differ by over a year. So on the left, it's December of 2011. Then there's May of 2013, then September 2014, January 2016, and June 2018 it is.
Mhm.
So that's its period is about a year. It's a long period variable, and it completely disappears from sight. You see, it goes down to ninth magnitude from just brighter than third magnitude. So the constellation looks like it's missing a star for a lot of that time.
Right. Right. And in fact, if you look at the sinusoidal path there, the data set, basically we can see that star in pretty good sky between the numbers 6 and 3. So you kind of, chop off that section of the cycle.
And it's only visible with the naked eye some of the time.
Yeah, above 6.
Yeah,
Or
that's
below
why
6,
people
and then-
called it, a wonder, right? Wonder, Mira, a wondrous one,
Whittemore, you once gave a very riveting speech to our club about Cepheid variables. What's the difference? What's a Cepheid? And is this one of those?
No, this would not be a Cepheid. So this is a long period variable star that is a carbon star. It's it's an aged star. Okay, so
Okay.
it has basically a lot of carbon in its outer atmosphere, and so glows red. Is beautiful red. Okay, the stuff I studied at Westmont when I was there were more short period variable stars called delta Scuti stars. So I was studying stars that were basically triggering cycles that were a couple of hours long. Okay, this guy is like 331 days, something like that.
Right.
Okay.
There's a picture of Mira in the images I sent.
Mm-hmm.
So is it basically a red giant that just gets smaller?
It's a supergiant.
Yeah. Yeah. I just call them carbon stars. Very, very large carbon stars.
Heavy on carbon.
Is that like
And
Herschel's
it's-
red garnet?
What's
It's
that?
also cool. It's also cool enough
Mhm.
for the carbon to condense as molecules in its outer atmosphere. So that's carbon stars.
Yeah.
So it
Tom,
rains
when you-
diamonds?
No, but there's carbon soot there,
Yeah.
and it puffs it off occasionally in clouds.
Tom, could you go to the picture of Mira that was taken by the Hubble? There it is.
Wow, that's a star. I've never seen. I guess it looks like a comet in a way.
Well, it's irregular, but
Oh.
this was with, I forget the name of it, but it's with adaptive optics.
Mm.
So that you can take out a lot of the atmospheric effects. And so this
Well,
is
I've
actually
seen by-
the cloud, the star, and its emitted stuff. Some of the pictures that Tom went over but didn't explain was the
Dust trail.
this star has a dust tail,
Mhm.
and that's what you're seeing here right at the star.
Oh,
Mhm.
I wasn't aware that Hubble had adaptive optics.
Oh,
Was
that's
that-
right. This is I missed that. That's
Check.
Hubble doesn't need adaptive optics.
Right.
It's above the atmosphere. So I'm correct. There's no atmospheric effect in there.
but that's not a radio image. We're looking at a visual.
It's visual images. The
Optical
one
image.
from the one from Hubble.
And the
Tom, you want to explain this one?
Well, this one says it's got Mira has a companion. They're showing them separated, it looks like. And that's what causes the variability, right?
That probably contributes to it.
Mhm.
it's a binary.
I
They're
think they were
orbiting?
showing that in this other picture here. showing that something's circling around, companion star. So is it a white dwarf that's going around a red giant that's
That's what
sucking
it
in the
says.
gas?
It says there it's thought to be.
Mhm.
Huh.
But yeah, that other picture, what was this picture trying to show here?
What's
It's
your picture?
moving. The star is moving and it's leaving behind a dust trail.
Yeah.
That's pretty cool.
Yeah.
Our variable star goes from magnitude 2 at the height to as faint as magnitude 10.
Okay.
You get, I
Mhm.
guess, but that time you definitely need a telescope or maybe a pair of binoculars. Can you see it with binocs?
Down to 9, maybe.
Yeah. Yeah.
I never see anything with binoculars. I can never hold them steady enough.
So we got Mira, and what is Mira? Let's see. It's named. It means wonderful, doesn't it?
Yeah.
Yes. Yes. Mhm.
Well, what's the Delta connection? What's that about? Besides being a COVID variant?
That's
That
another.
was just telling you how to find it in the sky.
Yeah.
Oh, I see. And what is Delta? Is it a star cluster?
No,
No,
it's
it's just
another
a star.
star in Cetus.
Yeah.
Oh, but Mira and its companion are considered one star, right?
Yeah.
Well,
Yeah.
you don't see the companion. It's dim.
Oh,
Yeah.
it's too dim to even see. Okay. Well, one of the most incredible things I ever learned from you guys years ago was that more than half the stars up there are multiples,
Mhm.
and yet we don't see that with our eyes. All we see are single specks.
Well, they're far away.
I guess so.
We do see some double stars as double, but they're
We
very
do?
they have very, very long-term orbits.
We also see black cats popping in and out of.
Bad luck.
That's the extent of our outreach this month, huh? That black cat.
What's the cat's name?
Shadow.
Shadow. Okay. I knew someone once that had a black cat and a white cat, and the black cat was named Snowball and the white cat was named Midnight.
Pretty good.
They got
Yeah,
together.
we had a
maybe-
black cat, and my daughter would name our cats, and she thought that Midnight was too common, so it's named Starbright.
Starbright.
There
Yeah.
you go. Fantastic. All right, this is a map of it, and this is in the east.
Mhm.
It's in the east in the evening and it's in the west in the morning. It's opposite the sun right now.
Okay. Aries and Pisces. So that's
Mhm.
the dotted line is the ecliptic.
No, the red dotted line.
the
is.
red dashed line is the ecliptic.
That's
Yeah.
it. Yeah. Yeah.
Okay.
No, so it goes right through a sign of the zodiac.
And then
Pisces.
Cetus is the whale, right?
Yes.
Yes.
Is there supposed to be a whale on that diagram somehow?
It's the sea monster that was coming to eat up Andromeda.
Oh,
And traditionally, where Alpha is up there has been the head of the sea monster. And down below where Beta is, way down in the lower right, that's the tail. But to me,
Yeah.
it looks more like a whale's head down below and a whale's tail up above. So you'll see different pictures of it.
Uh-huh.
so if you were an ancient man without a telescope, but you happened to pick a favorite star at night and it was always there and it was Mira, it would go away after a while, right?
Yeah.
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 And
Very
then come back.
confusing.
Yeah. And all your friends around the campfire would think you were crazy.
Right.
But the sky changes, of course, with the seasons and everything else, but you can still take heart with the fact that everything is the same. They're just moved, right? You'd know where the Big Dipper was and the North Star, et cetera.
Some of them over very, very long periods of time. Some of them have changed shape slightly, over 100,000 years.
Yeah. Well, I remember my grandpa when I was age 5, pointing up to the Three Sisters in Orion, and they haven't changed 70 years later. I don't understand.
There's a star that's moving very rapidly. What is it? Barnard's star?
Yeah.
Yeah.
Barnard star is one. Yahtzee star is another one.
Yeah. Some of these stars, you can actually see them over your lifetime in a different position.
Yes. Yes.
Is that
From
right?
one year to the next, if you take photographs, you can see the difference.
Yeah.
Okay, there it is. That was our.
Okay.
Did you see that note from Tim Crawford? He was saying that was there 253 was in that area and he saw it through Tom Whittemore's 18-inch scope one time.
Yeah,
253, what's that?
And Jerry,
NGC?
Oh, NGC, okay.
NGC 253. Yeah, it's a galaxy. I think didn't.
He said something about the
Carolyn
silver
Herschel,
dollar.
I think, right?
Yeah, silver dollar. It's called the silver dollar. Carolyn Herschel, I think, actually maybe have named that. But yeah, it was one of the first. I understand, Jerry, you went to CalStar. Is that right?
Not this year.
You did. Okay. I was going to say I was at the one of the first ones because our club used to run them in 2001. But
Yeah, back then, yeah.
him and I saw it. I would say it was more like 2009, 2010. And I brought the 18-inch, homemade 18-inch there, and I just aimed it right at the sculptor group down there. And 253 came right out, just oh my, beautiful. You could see the stippling, because it's a side-on. It's a side-on galaxy.
Flocculent galaxy.
Yeah.
Yeah, CalStar this year is October 7 to October 10.
Oh, okay. So it's coming up.
Yeah.
Are you gonna-
That's why the weather's turning.
What's that?
That's
Are you
why the
gonna go?
weather's turning.
Oh,
And none of you
Got
are
it.
going.
Yeah.
Nobody's
It's going from overcast to more overcast.
Yeah.
the totally dense overcast.
Wow. Wow.
Would it be fair to say that most of the stars we see at night, if we can see them and they're bright and big enough, have a name, but all the peripheral ones that might require a telescope or come and go, like our variables, get a phone number, like Tom was telling us?
A
Yeah.
license plate number.
Yeah. Henry Draper number, HD this, HD that.
Yeah, there's tons of catalogs.
Yeah. Struve, Otto Struve.
Mhm.
But
Most
you
Struvas.
use the letters NGC. What does that mean?
New General
New
Catalog.
General Catalog. That was new in 1885.
Yeah.
And
That
is
was
that a-
started by William Herschel.
Mhm.
Mm-hmm. Mm-hmm.
Tom, if you're going to put something up, you need to explain it.
Yeah, what is
Yeah, I was just trying to wait for a break. So this is the area you're talking about going for the CalStar is, where is that at? Right about here somewhere, huh?
Yeah,
Well,
in
let
the
me look.
storeroom
Where's
right
the-
now.
It's not an easy map to see.
It's California.
San
California.
Joaquin. Yeah, it's east of Paso Robles.
Mm-hmm.
Oh, so it's hot.
Oh yeah, it's very hot there when it.
Yes. Yes.
Be nice to have a convenient lunar eclipse, wouldn't it? Some night if it hit that, but that never happens, does it?
We do
Go
have a
watch.
lunar eclipse coming up next month.
Yeah.
Yes.
Really?
But CalStar is always centered on the new moon because people want to go there and see very dark skies.
Yes. Mm-hmm.
And all those shadows in the crescent.
Well, no, the moon is usually not in the sky. If it is, it's a very small crescent that sets while you're still setting up your telescope.
Yeah.
Is that right?
Yeah.
Mm-hmm.
How long of a period is that when you can't see anything, any crescent? What is it, about half a day, 12 hours? Just
No,
black?
it's about two to 3 days. There was a contest in one of the magazines a few years ago for people to turn in the earliest possible crescent they could see. And I think someone made one that was about a day.
I think it's down to a couple of like 10 hours for some of them now. Some of the really extreme ones.
Yeah, they're probably getting better at it.
Hmm.
Yeah.
The only rule is you can't use a spacecraft.
You're talking about the Hubble Space Telescope. We're looking at Mira, and I just found this picture of the Hubble being polished here. It's kind of get an idea of the size and how they were doing it.
Oh, look, I can see there's a pin that's put in wrong up there.
Very funny.
Bartender, set them up for everybody. Pull your chairs up, guys.
Yeah,
The hell is that?
So,
that's the inside of the Hubble before they put a spacecraft around it.
Oh,
so it's a truss tube setup.
Yeah,
Yes. Yes, it is. And I think the mirror is 94 inches, right, Chuck?
yeah, that's what I
84,
remember.
isn't it? 84?
94.
94, I thought.
94
Just
inch.
short of 8 feet. Yeah.
Yeah. It's
It was
amazing what you
8.3
can see.
meters.
there it
That
is.
can't be. That can't be.
It's your basic model for, you suppose they sell a model of the Hubble you could build just like a little airplane?
Yeah,
Yeah,
there's paper models of it that you can
Yeah.
get.
Really? I'll be
I
damned.
think Lego has one, don't they?
Probably.
Yeah, but that's full size.
Yeah.
That's pretty good.
Isn't it on its last legs? Only due
Doesn't
for
have any legs.
any legs,
Yeah.
but it's still an
Uh,
arm and a leg to book it.
Yeah,
I
it's
guess.
They
died a
forgot the
couple
tripod.
times. It's died a couple times. They brought it back.
Oh yeah,
They're going to deorbit it in about 10 years.
is that right?
Yeah.
Deorbit. You mean let it plunge through the atmosphere and burn up?
Make it plunge through the atmosphere.
That seems a waste. You know, they should just boost it higher and wait till the Smithsonian can go get it.
Well, Elon may take care of it.
Yeah.
All right, gentlemen, you all got some of President Jerry Wilson's forwarded cartoons. If Tom has time to call any of these up, we can join them. There are
Okay, we'll
there's
do the dinosaurs looking up here.
Okay, apparently the Museum of Natural History, not ours, we have
Where'd it go?
life-size, real-looking dinosaurs wandering around in the back, but apparently, where is it? I just lost it. Here we go. They're bones of the Tyrannosaurus. They unearthed several, and they have proof that giant asteroid must have wiped them out on 65 million years ago, because they're all pointing upwards with their bones, their little tiny arms.
Here we go. Sorry, they're hiding windows.
There it is. I admit the discovery does seem to support the asteroid theory. Those would be baby T-Rexes, or what's called the Allosaurus, or maybe even, what's the other one? The
Velociraptor.
the raptors. Okay, there's others, but we got to talk about other things. Asteroids, you want to go there, or you want to go to the biggest comet ever seen in recorded history? Shall we go there?
You're the driver.
Whatever you like.
Comet, let's see if I can get through this. The two guys that discovered it a long time ago, Comet Bernardinelli-Bernstein, or C 2014 UN27, named after the two discoverers, Bernstein and Bernardinelli.
I think it's UN 271.
Oh, yeah, right. 271. I made it one there, and I thought it was a slash. Been designated a comet, even though it's darn big. June 23rd of this past summer. It's 1,000 times bigger than most comets. There it is. Look at this. Typical comets are relatively small, like asteroids. I guess they got more water in them, perhaps. But this sucker is anywhere between 62 miles in diameter to 124. But it's way out there, past Neptune.
On its way in.
Okay. It's out of the Oort cloud. And how many millions of years, 3 million years its orbit, get around the sun? So we won't see it better than this until 2031, at 10 years, closest approach to Earth. And even then it'll be 10 AUs out, right? Right now it's about 30 astronomical units
See.
out at the edge of the solar system, or at least the planetary solar system. Largest comet ever seen, ladies and gentlemen. And it was first spotted in 2014. I believe Tom Totten told us that. Now at the equivalent distance of Uranus, which is not the furthest out. That would be Neptune. So it's past Neptune. Is this the one that's at an angle? No, that's the asteroid we'll be talking about, Pallas. We get to that.
This one may
not very
be coming
broad.
in at a fair angle too, though.
Yeah.
So
Inside that circle is this giant comet.
That circle that's what the comet looks like right now from Earth. No tail, just a dot. So it's got to get much closer to start boiling off any volatile materials it has on it.
it does have some small bit of coma already, though, that they're seeing. And there was an occultation campaign recently in Australia. In around September 19th, there was an occultation of a star by this comet.
Oh, really?
And there was a group of people that went out across the path in Australia. And I think it was 7 teams that went out to try to get an occultation. And I think 4 of them got clouded out and 3 of them got data that didn't show anything. So they don't have the position nailed down, but that would have helped them get the size. If they had actually gotten an occultation, they would have been able to narrow it down from the size range that they have now.
Yeah, because the size range is based on the brightness estimate and a guess at the albedo of the comet.
Huh. Well, any coma or corona or whatever is around a cloud doesn't stretch out until it gets into the near sun, right?
Till the solar wind is really hitting it. Yeah.
Yeah.
It has to heat up a bit.
Do you know, I remember in junior high school, a science teacher saying, all the tails on these comets that come around the sun are pointing away from the sun, and science doesn't know why. And I sat there back then. That's what he said. They didn't know the reason. I said, I know why. It's because stuff's blowing through it.
Yeah.
The sun.
Yeah. Solar wind.
Yeah.
Yeah. Mhm.
But here,
Okay, here you can see it's a pretty high inclination orbit.
Oh, yeah. Wow.
oh, okay. Oort cloud is not on the ecliptic. It's
No.
its own ball game.
It's a shell, a spherical shell.
Mhm.
yeah. Interesting.
Probably. This shows that it's not going to get any closer than the orbit of Saturn.
Okay.
Well, I have a question. Maybe you guys know. You showed the picture a while ago of the tiny little, barely see the dot.
Yeah.
And the only reason they would conclude, looking at that that's a comet, is that it moves in relation to everything else, which is stationary behind it.
Right.
Or an asteroid, comet or asteroid.
Okay, there it is. Now, if that sucker's moving, all right, I got that part. How do you know which way in 3 dimensions is moving? How do you know if that movement is toward us or away from us? How do they figure that out?
You have to take multiple measurements over a period of time, and then you calculate the orbit.
If you get three measurements, 2-dimensional measurements like this is sufficient, and the knowledge that it's in orbit of some kind around the sun, and then you can fit the various possible orbits to those 3 points, and that gives you the total motion of the object. Because you know it's not just an object free in space; it's an object that's in gravitational coupling to the sun.
Mhm.
So it has to be in some kind of a conic section. And
Plus,
so
it
those
also
3 points let you pick which conic section it is.
okay.
They have to be separated by a fair amount in time when something's really slow moving like this too.
Right.
So I got a question for you. What does the word ephemeris mean?
That's
Ooh.
the predicted positions for it.
Yeah.
Yeah.
It's a table of projected, right ascension and declination.
Tom Whittemore, do you know what the Latin word how in English would be? Translate from the Latin ephemeris.
I think
It means
ephemeris
time
is Greek.
series.
I think
Is
it's Greek. Isn't it Greek?
Yeah, it's from Greek also,
Okay.
and it says that it means diary.
Oh, I see. That's neat.
Okay.
Interesting.
Well, apparently it's comes from 40,000 AU away, and that's way out there.
Yep.
Wow.
Trillions of comets out there. This is one of the largest we've ever seen, as we said. But if it's a 3 million mile time span, 3 million years to get around, it's coming in pretty fast, considering it's got such a long orbit, wouldn't you
Well,
say?
it's been coming in, they say, for millions of years.
Oh,
So the orbit is what, 3 million, I think it said on here somewhere.
Yes.
Yeah.
3 million.
It was
Yeah.
last in the vicinity of the sun when Lucy was walking around in Africa.
Yeah, that's right. And apparently they found it while they were mapping 300 million galaxies out there.
Uh-huh.
The Chilean telescope, along with TNOs, trans-Neptune objects.
Yeah.
That would be comets, wouldn't it?
It was the Victor M. Blanco telescope in Cerro Tololo.
Mm.
Yeah, TNOs
Chile.
would be asteroids and comets, or Kuiper belt objects and comets.
Yeah.
We got the Kuiper belt in between, but that's on the ecliptic, and then you get to the shell, which there it is. Look at that, man! Oh man, there's a lot of comets in that ball. No tail yet, but a coma of gases, you said, and dust, and it's heading our way. And are you gentlemen thinking in 10 years, assuming we're still here, with our telescopes, we'll go out and see Bernardelli Bernstein and his orchestra? Wow. Comet from hell. I love it.
Mm.
We're at the halfway point. Can we talk about another one, the termite mounds, or you want to do? What's the other silly that we got from President Jerry? He sends out some incredible. You call it up, Tom. Oh, what do we got? More?
Oh, sorry. Just ignore that. I'm not.
Well, apparently scattered across an African plain, there's a caption proclaiming, like frozen, what is the word? Centuries of the Serengeti, the big mounds had withstood all the blasts of time, time and foe, until a horde of drunken aardvarks. Is that the same as anteaters? Is an aardvark?
Yeah, they are anteaters, yeah.
Apparently arrived to take out the termite mounds with wrecking balls and terrible. You'd have to see the cartoon. It's coming. There it is. Now you can read it. We keep a lot of these things back on Earth. I love it. Great stuff. Where do you get all that, Jerry?
I don't know. It just sort of crops up on my Facebook feed.
Yeah. Yeah. I started forwarding stuff I get too as a result. Thank you, Tom. You did good. So we talk asteroids, gentlemen. This was on the talking points last week and we didn't get to it. And these are large. For
look at this one. Look at this one.
Oh, God.
Oh, yeah.
A water bear.
Water
hunters.
bear.
Yeah.
Is that what they call those little mites?
Yeah. This is the last of the species of the giant water bear.
And those suckers live forever and can live anywhere and under any
They
circumstance.
appear to be fairly resistant to harsh environments like interstellar space.
God, there's a Steven Spielberg movie coming. And I can, that's
Yeah. Okay.
water bears. I love
Okay.
it.
Back to reality. Daphnis.
Back
Daphnis.
to Harmonia, Julia, and Pallas.
Oh, you want to do those? Okay.
Yep. I think Daphnis would be much more interesting, the gravitational effects in the rings of Saturn there.
There you go. So we'll squeeze it in because I didn't get much detail. It's a shepherd moon of Saturn. It's between the two outer rings, or it's next to the biggest ring, isn't it? Just 5 miles across. It's a moon, and it shepherds the stuff in the rings around Saturn, orbits inside the Keeler gap.
Yeah.
Go ahead. There it
It's
is.
it's in the A ring out there, and the big gap out that's it out there. That's the Keeler gap. And here it shows the Keeler gap and Daphnis these are from Cassini spacecraft.
Wow.
And this is a shepherd moon. It's cleared out the debris in its orbit, which I think qualifies it as a planet myself.
I was going to say that.
Cleared the orbit.
It's not orbiting the sun.
Yeah, well, it is.
I
And
get
then it shows these things in the wake of it that are on the outside. The ring is, let's see, which way does it go? The outer ring is going slower. So this thing is passing the outer ring. It's going down to the left, but the inner ring is going faster. So the scallops are in the wake of the shepherd moon on the inner ring, and then the wake of it on the outer ring. So you see the scallops go in different directions. And then,
So Jerry, what do you think the relative difference in speed is?
I would have to sit down and I don't know. For that, I'd have to have a lot more numbers than I have to estimate.
It's not going to be real fast.
No, it's not real fast. These are very slow events. You wouldn't be able to surf it. And then there's this very dramatic close-up of Daphnis in the Keeler gap.
And some of these shepherd moons end up looking like dumplings because if they have a steady orientation, they start to build up debris that they've pulled out of the rings around their circumference, around basically their equator. And you can see a little bit of that maybe happening on this one.
Yeah, they've got a waistline problem.
Yeah.
Well, what do you call those waves on the left?
I call them scallops.
Scallop.
But, yeah, they're I'll forget the term for it.
Perturbations.
Yeah. Disturbances.
Oh, Jerry, this picture is kind of neat because it shows the waves on the inner on one side and then the waves on the outer on the other side.
Yeah.
That's because of the relative speeds of the orbits on each side.
Mm-hmm.
So is that little moon sweeping up stuff, all those little pieces of rock and ice, or
It's kind of scaring everybody back into the ring.
scaring everybody?
Yeah, it's actually gravitationally repelling them or attracting them, I guess, is into the ring, back into the ring.
Okay, but the theory is that the rings were a planet, or not a planet, but a moon at one time, right? That broke up.
I'm not sure about that.
Yeah, the current best explanation is a moon roughly the size of Titan came within the Roche lobe of Saturn's gravity and got disrupted, and the icy parts ended up forming the ring,
Yeah.
and maybe any kind of silicate or iron parts ended up falling into Saturn.
Yeah, that's a good story. So
So is Daphnis considered one of?
Daphnis is too strong to be pulverized by being inside Titan's Roche limit.
Or
So it's
Saturn's
remained
Roche.
whole.
Roche limit. What does that mean? I'm sorry.
That's how close a given object can be to a bigger object before it gets torn apart by tidal forces.
Oh, gotcha.
And that distance varies depending on what you're made out of.
Yes.
That's right.
Well, Io around Jupiter is pretty close to it, wouldn't you think?
Yes, and that's the source of its internal heat that gives it the volcanic activity, is the twisting and squishing and turning, all the friction of its tidal forces. But it's not enough to tear the moon apart.
It looks like a large pistachio there in space. Well, and does it collect the stuff or does it not? It just bounces off and goes back into the ring.
It collects some. You can see some forming those ridges on it.
Yeah.
But mostly it keeps the edges of the ring sharp.
Mm-hmm. Those if there's a candidate for an alien spacecraft, Daphnis is more suggestive than Oumuamua.
Yeah.
But now, did we know this existed before the Cassini went up there 2 decades ago?
I don't believe it was seen until Cassini looked at it.
But there's others too.
Probably knew that this kind of effect could happen, but we had an inkling that there were moons like that there, but Cassini went and looked for them and saw them.
Yeah. Here it says that the position had been inferred from gravitational ripples.
Yeah.
And then discovery was by Cassini right there, 2005. Yeah.
Does anybody know how they've named those rings or why they put A on the outside and it goes B, C, D toward the planet? Then I think
those labels for the rings are very old. They come from the first visual observations of the rings and then finally seeing gaps in the rings, and then they labeled them A, B, C, D, and F. So.
Yeah, the A, B, C is sort of historical, and they were named from the outside in, but then as they found new ones, they continued with the alphabet, and some of those are much exterior to the A ring.
Yeah.
Didn't the Cassini probe go through the rings?
Yes.
At one point, one orbit it did, yeah.
But that was interior to the D ring. It was very close to the planet.
Yeah.
Oh, okay. But they still held their breath.
Yeah.
All it would take is one big chunk of ice and that Cassini's gone, I would imagine. Look at this. Wow.
Tom, I sent you an artist's conception of what happened to an icy body that came too close to Saturn and actually got pulled apart.
That's the old Roche limit that Chuck was
Right,
talking
exactly. Right.
about. Is that named for somebody named Roche?
Quite likely.
Yeah. Brother of Hal.
Yeah.
But that's ROCHE,
Yeah.
not ROHCH.
I'm
Right.
taking a little bit of license there with my
Irish.
Joe.
I think he was an Irish mathematician, Roche.
Well, is it my understanding Saturn has the most number of moons in the solar system?
82 at this point.
And that
Known
include-
moons.
Is that what? What did you
Known
say?
moons.
Known. It doesn't include Daphnis?
Yes.
Yes.
Okay.
And
So
they just they think they found a new one around Jupiter, so it's up to 80. So it's trying to get its title back.
And poor little Mars has what, a couple of asteroids that we call moons, Phobos and Deimos.
Yeah.
Well, you work with what you got.
Yeah, I suppose so. Venus
And
doesn't
they're
even have
thinking
one.
that those are actually pieces of stuff blasted off of Mars by the Hellas Basin impact.
Oh,
Because they're not in a likely orbit for a captured object.
Yeah. And they're not in stable orbits.
Well,
They're
that's-
going to eventually crash back into Mars.
is that right? And we got a jillion moons if you count debris, anything circling a planet. You know, what I wonder is, when does a binary system, and that applies not just to stars, it can apply to asteroids, two of them going around each other, or a big star with a little star, you know, like Alpha Centauri. When does something going around you cease being a planet and becomes a moon? Because if our moon was bigger, we'd probably be going just like a binary system, wouldn't we? And it wouldn't be a moon, it'd be a partner. Do they have a
Yeah.
dividing?
The definitions are all fuzzy, Ron.
Yeah.
Is that, well, that's what
And
I'm thinking.
Well, look at
controversial.
Charon and Pluto. Charon is what, a third the mass of Pluto or something like that?
Yeah,
It's still called a moon.
Mhm. I think the rule is if the common center about which everything is rotating is inside the major body, then everything else is a moon. And if it's outside, then it's a double.
and
Yeah, but
they
the
orbit
common
it.
rotation of Charon
Everybody
and Pluto
froze,
is
so I guess-
outside of Pluto.
Yeah.
Plus there's there's a second moon around Pluto, isn't there?
Well,
There's
there's
five.
several now.
There's
Several?
5, yeah.
I didn't know until, what's the name of that? New Horizons, right?
Yeah.
Mhm.
Here are the
Oh, this
dumplings.
This picture shows Chuck's waistline problem for the shepherd moon.
Well, these are other shepherd moons.
Yeah.
Daphne's the baby, huh?
Yeah.
Mhm.
And Atlas is okay, it got a name, Atlas, and Pan. That's Shakespeare, isn't it? Pan, or no, what am I thinking? That's
Greek mythology, probably.
mythology.
Yeah, it's Greek mythology, but it is a character in Midsummer Night's Dream.
I've lost some weight on this thing, guys. I used to look like that. I'm better,
Okay.
kind of lumpy. We got about 20 minutes to go, and that's our 32nd episode of the SBAU Astro Hour. All
Here's-
gang
here's-
on duty.
Here's Bruce's Roche limit image.
Oh, coming apart.
Yeah,
Is
that's where the gravitational forces exceed the self-gravity of the object, and it pulls it apart.
Yeah.
But that's an artist representation. It's not a
Yes.
photograph.
Oh, yeah.
Yeah.
But it was an icy giant that came in close to Saturn, and Saturn's gravity pulled it apart.
Well, now, what was it? Shoemaker-Levy that broke up in the 90s as it plunged into Jupiter?
Yeah.
Yes.
Is that
It
similar? to
broke
what
up
we're
into
talking-
7 pieces.
It left a bunch of black spots.
I think when the comets break up, because they can break up all sorts of places, not near a massive object. I think they just blow off, they get hot and a lot of their structure leaves, and pretty soon the parts just are no longer connected.
But it was definitely the Roche limit type forces that stretched it out into a line so that the
Oh,
pieces
yes.
were coming in bing, 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 bing.
Yeah.
But now this requires the body that's coming in to have an angle to it. If it were going right at it, it would be similar to the situation that created our moon. A body actually, what they thought maybe the size of Mars.
Mhm.
Actually, something we've never seen and probably will never see is two giant bodies, planets or giant asteroids, actually colliding and bursting into.
I think we've seen evidence of that in some exoplanet systems where
Right.
we see a ring of debris.
Yeah, I recall that too, that they claim they were imaging the system or looking at the system, getting data out of it shortly after on an astronomical scale, the collision.
And they two bodies actually collided and they were
Yeah.
watching.
What
And
they-
Ron, when it's coming straight in, if it's icy coming into one of these huge gravitational wells like this, you'd still get the Roche limit effect and the thing would break up before it hit. It wouldn't just come in and stay solid like a BB or something like that.
Oh,
You'd still get this different at some radius, you'd still get this differential tidal force, just like the moon is pulling up our tides on both sides of the planet. That would start to stretch it out.
Mhm. It's the extreme version of it is what's called spaghettification. If you,
Yeah.
you imagine a person falling straight into a black hole.
well then any of these scary stories about the asteroid from hell that's going to wipe us out like the dinosaurs, it would do it on a massive, many pieces scale, not just one 6 mile across rock hitting the Pacific or whatever.
Depends how strong it is.
Yeah.
Well, how do they know that's not what happened with the dinosaurs? They only have one location, and that's
Yeah, they found the impactor buried under the Caribbean. They're drilling into it.
Right, Yucatan Peninsula.
Plus, there may have been other secondary impacts, but that was the major one.
Yeah.
Yeah. And all those dinosaurs going, look at that. What's going on?
You remember one of the I think it was the second Star Wars movie where they were on Endor with all the little mouse-like, whatever they
Bears. Yeah, little bears.
Yeah, and then there was a Death Star in orbit around that moon, the moon of Endor. And then at the end of the movie, the Death Star blew up. And it was a 500-mile in diameter object that just became into pieces. And someone pointed out after the movie was viewed that if that had happened, the fact that the thing was destroyed and all those little pieces entered the atmosphere would have had a similar effect to our Chicxulub impact. That is, it would have been spread out, but it would have killed all life on that moon, just from those parts re-entering and heating up.
My understanding was the Death Star was the actual home of the bad guys, the dark side, Darth Vader. They flew in and out of that.
Yeah.
Okay.
But it had to be big and it had to be massive. And when you have that kind of mass uncontrolled in orbit, it's going to deorbit.
Was that
here's a picture of that silver coin galaxy that Tim pointed out earlier.
Oh, okay.
Tim Crawford?
Oh, yeah, NGC 253.
It's also known as the Sculptor Galaxy. Yeah.
Yeah, it's in the Sculptor group.
It's not a pinwheel?
It is, but we're seeing it kind of obliquely.
Yeah, you can kind of pick out what looks like spiral arms in it.
Huh. What are those?
Maybe if we send a camera out there, we can get a different view of it to make it look more like.
Yeah, I'm not going to wait up for it.
Ones that fascinate me are those giant cotton balls that aren't in wheels or anything. I don't know how they orbit or.
Oh, you mean the
what do they call
it? Cluster?
Irregular galaxies?
Elliptical.
Elliptical, yeah.
Elliptical galaxies.
Yeah.
Well, there's some that just look like big cotton balls.
There are.
Okay.
I don't think it's completely clear how galaxies evolve and turn from one into another.
Yeah, a lot of them are
collections. To me.
Yeah, I understand a lot of them are collections of other little galaxies, and they all collide. All hell is going to break off in 5 billion years when Andromeda gets here.
Okay. Well, in our remaining 10 minutes, we got to cover the galaxies, or I mean the asteroids in our system.
All right.
This is our last chance because I'm not going to add it to another weekly discussion.
All right. 40 Harmonia, 66 miles across. 89 Julia is 90 miles wide. And asteroid 2 Pallas, also known as Aquarius.
No.
Well, those are the three we were talking about.
Yeah,
right?
but Pallas isn't also known as Aquarius.
Oh, it's an Aquarius. That's
a constellation.
Okay. Is this the three of them, or just a view of one of them?
No, these three are in the sky right now, and they're roughly in opposition to the sun. So they're like straight up at midnight. So if you want to look at them and take pictures of them and compare them night to night, this is a good season to do it, provided you don't live in Santa Barbara.
Yeah.
Now, we can't see them with the naked eye, can we?
No.
Certainly not Julia and Harmonia. Pallas, you can certainly see it in a very small telescope or binoculars.
Okay. And Mr. McPartland, do you ever see stars get occulted by these babies?
I don't think I've had an occultation of Pallas, but it does happen.
Let's look at that Pallas picture that Tom has up right now. These pictures are made by computer analysis from the light curve over a long period of time. watching minute fluctuations in the light curve as the asteroid rotates. It's a nice algorithm that's been developed to get a rough idea of the surface. And you see there's a very, very bright white spot on the right-hand picture at about 10 o'clock. Yes, right there. And that is that's reminiscent of the very bright spot that has been seen on Ceres by the spacecraft that orbited it. I forget the name of the spacecraft now. But
New Dawn.
What's that?
New Dawn, I think it was.
Yeah, that's right.
Dawn, but Dawn was in there.
Yeah. And so that was on that Ceres was believed to be is believed to be full of water, and the very bright spot is due to water that's come out and deposited salts on the surface and then evaporated away, leaving this very bright white spot on the surface. So the suspicion is that Pallas is also a smaller version of what Ceres is.
I just looked it up, and I did get a positive on a Pallas occultation in July of 2016.
Oh,
Wow.
you did?
Yeah.
Okay. Do you have that data available?
Let me call it up here.
Okay.
Pallas is apparently the biggest of the three.
Of
It's
these three, yeah.
400 miles across.
But if you go back to this is Ceres. If you go back to the image of what is it, Julia, you can see a similar model attempt at that, and it shows a very large crater in the center of the picture of the thing, and the crater has been named. They're so certain that it's there, and its name is Nonza.
Yes. Got that here.
Okay.
That's the second name. The first is Hugh. Humongous.
Okay, I have my Pallas data, some of it.
Okay.
Share screen.
All right, go ahead.
Okay, and
Name for Greek goddess Pallas, Athena. Third largest asteroid in the belt.
Wow.
yeah, so this is one I just kind of got the edge of it there, that top chord.
It's yours.
Yeah,
Okay.
Blue.
yeah, kind of bluish, and then the two others were people in various other parts of the country that
What's
also
with-
did it.
What's with number 4 there?
Number 4 is
predicted.
the predicted center line and the predicted time of start and end, so it was offset a little bit
Yeah.
from the prediction, which is odd considering Pallas has got such a long history of astrometry.
Yeah.
You'd think that they would have known the orbit better.
Yeah.
Well, this is the
Okay.
one with a strange angle, isn't it?
This is
Yeah.
the one that's about 45 degrees off the ecliptic. Yes, in its orbit.
Well, now that just begs all kinds of questions. Does it intercept the asteroid belt and then go through it?
Yeah,
It does, and never hits.
twice,
the middle.
going down and going up.
How did it get like that, do you suppose?
It interacted with some other object.
That's
Good
how it happened.
question. Good question.
Yeah.
Well, I grew up not hearing that asteroids were cruising around everywhere. One might hit us. I never heard that until I grew up. So do they ever go around the sun like a comet? Do they have the same stuff in them that would make a tail? And that's not a comet, but an asteroid?
Yeah,
They do.
the definitions are fuzzy. The
Yeah.
Phaethon, the parent body for the Geminid meteor shower, is occasionally shows kind of a coma, but it seems to be from sodium being boiled off of it. But they think it's a burned out comet hull. Okay,
Wow.
here's actually, they have some, like you showed the model, Jerry, based on the light curve.
Yeah.
Here I can share. This is a light curve fitting to the occultation data.
Oh, okay.
Huh.
So it's very similar. It's not showing your white spot, but that might be the flat spot at the bottom there.
Yeah.
Looks
No,
like
it's
a
probably
belt.
on the other side.
Yeah.
The
I mean,
fact
this
that
is just a reconstruction, so it may
Yes.
not be showing albedo features. It's just showing surface the surface of the asteroid projected.
Resulting surface from the
Yeah.
model. The fact that the orbit is slightly off could be from one of the passes through the ecliptic plane. It might have come close to something enough to tweak it a little bit.
Yeah.
Is
Or
this-
the star position isn't quite accurate too.
Yeah.
This is back pre-Gaia, I think. So it may have been the star that was off.
So on the basis of 3 occultations, they're able to get the whole feature of the
No.
asteroid.
Well, you get some features, but this is taking a Dammit model, and they probably have several for Pallas, and fitting the best one to the occultation chords.
So how do they get the depression there at the bottom?
That's from watching the brightness variations.
Yeah, it's not from the occultations.
Yeah.
And there's another one. If you look up at Harmonia, they have a picture of 3 different facets or sides to Harmonia, all projected from this algorithm that estimates surface features from the light curve. Now, the surfaces look much smoother on this because the asteroid is much smaller. And so they can't resolve a lot of points over the surface.
Do those numbers before the names of the 3 asteroids, is that the time, the number that they were discovered?
Yes.
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 So number 2 is Pallas,
Yeah.
and they once thought it was a dwarf planet. It's not quite spherical enough. It's
Well, no, it was called a planet until the 1800s when
Right.
photography came along, and then they said, "Oh no, these things are like rats."
is Ceres
Go
asteroid.
the other way, Tom. There you go. No, that's Julia. Go up, or no, that's Pallas. Yeah, go back up toward Harmonia, where there's 3 pictures in a row, 3 images in a row.
There we go.
Yeah, and so this shows it's fairly featureless because it's fairly small, and so this algorithm doesn't resolve a lot of points over the surface. But it looks
That's
like
different rotational aspects of it.
right. They did capture the rotation. They fit the rotation and the surface features to the light curve.
I'm sorry, I got lost. Is that Harmonia or Pallas we're
This is
looking?
Harmonia.
That's Harmonia, the smallest. It's only 66 miles across,
Yeah.
which isn't enough to make it shrink into a total ball.
Isn't that the size of the Chicxulub impactor? About 60 miles?
6 to 9 miles, somewhere
6
in
to
there.
9. Oh, so
7
this
miles. Yeah.
this would really damage things.
Here's a
Okay.
nice picture of comparison of sizes.
Oh, look at that. Rocks are us. Pallas, Vesta.
You don't have Ceres in there.
No, Ceres not here.
Series
It's a little bit bigger.
Yeah.
It is a planet, or a little planet, dwarf.
Dwarf planet. Yes.
Is it bigger than Pluto?
No.
Pluto is bigger.
There's Ceres.
Yeah.
Oh, there it is. Look at that. At what diameter does it straighten out and become a solid ball?
Well, it depends on what it's made out of.
That's true. Yeah, you're probably right. Yeah. Amazing. Things do not do well when they collide.
Here's in the top image is Phaethon there. That's that parent body for the Geminid shower.
The big one on the left.
Yeah.
Oh, there's an asteroid shower going on right now this month.
Yeah. Well, the Orionid's around the 20th of October.
A meteor shower.
Yeah.
Seemed like there was another one.
The moon is full.
But meteors are not necessarily from the asteroid belt. They're not little asteroids.
Well, yeah, kind of.
They're from asteroids and comets, and there's no real difference between a comet and an asteroid except frozen volatiles.
But
So-
the meteors were in the tail, right? Going through the tail, and that's why we get a shower.
Yeah, it is basically, but also the solar wind can charge up pebbles on the surface and then they electrostatically repel each other. That was seen recently with one of our orbiters that went around an asteroid or a comet, and they saw things coming off of it that they
That was
thought were star
Bennu
clusters.
and Ryugu. Yeah.
That's it, yeah. they thought were star clusters they hadn't noticed before. And then they thought, well, they're changing every frame of the camera. So it's just emitting pebbles. And so that will eventually show up as a meteor shower. When you see a real fast white meteor that doesn't last very long in the night sky, that's something between the grain of a size of a grain of sand and a marble. So it doesn't take very much to light up for a short time.
Just wanted to mention these guys, the new astronauts got their wings.
Oh yeah, the regular citizenry.
Yeah, that's a little controversial that as I read it, they did not do astronaut training, so they're not really astronauts, but they do get their wings for having been in space.
I recommend looking at the Netflix series of like 5 videos they did of these guys training. They did a lot of training. I think they did pretty good. And I wanted to see the actual picture of their of that little pin they got. They have a better picture of it right here.
Slender guy on the right is
see, that's totally a Musk pin. That's not really.
Yeah.
It has crew on it. Yeah.
So they got their dragon wings.
Yeah.
Yeah, you're right. You're right.
How many of us would go if we had an invitation and it didn't cost us anything? I wouldn't.
Oh, I'd go.
Oh,
You'd
sure.
go in a heartbeat, huh?
Yeah, it'd be worth the view, I think.
Yeah.
Provided you were able,
Provided what, Bruce?
you were able to get back to Earth.
Yeah.
Yeah.
Well,
And they
provided you were able to get up there.
If
and
you didn't
provided they
make it-
kind of fix the toilet.
Yeah. Oh, was there a problem with the toilet?
Yeah.
Oh, I can't even imagine. We don't even want to go there.
That's what the barf bags are for. Yeah.
We have run out of time, gentlemen. Obviously, still very, very alive and well, and the SBAU continues to function. Maybe we'll all get behind closed doors someday again. Who knows? In the meantime, we'll close it down. Take it easy. Take care of yourselves. Go love your wives and Tom Totten and I guess the other Tom Whittemore and Bruce. We're going to buy our Teslas and start a gang on the street.
I'm getting a Ford F-150 Lightning. That's what I'm just going to go for.
Okay.
I'm keeping my 2009 Chevrolet Suburban with 5.3 liter V8 gasoline engine.
Good to see you again, Tom W.
All right, guys. That was number 32. We'll do 33 next week. Thank you very much.